2D platter from scratch. To catch everyone off, or catch everyone up, I should say. So, a few streams back, I built this little guy, which basically was a modification to my 3D printer to write out some G code, and I wrote a little Python library to do that. And I decided to actually build a little plotter instead of using my 3D printer, since I just want to get back to my mechanical ways. So if we go back historically, I've made several attempts, one with connects and rubber bands and such, another one that got as far as the wooden frame, and then just some Python that I used with a laser cutter, and none of these really scratched the itch. So I figured I would take this design as an inspiration and start to work towards a CAD model. And so this is what we built last time. Let's see if this gets, nope, totally doesn't get to where I want to go. All right. So to remind ourselves, because we left off with to-do list. So add another stepper motor. So this stepper motor here controls this bit sliding along this rail, but we need another way to move this whole assembly here along this rail. Got to figure out how to lift and drop the pen, how to hold the pen in place, how to attach belts to the stepper motors, find a place for some home switches. So the idea of home switches is that you'll be able to find the home. So if this was x equals 0, y equals 0, and this was x equals, I think this is 400 millimeters across, 400 millimeters down, this would be x equals 400, y equals 400. We want some switches over here so that we know how to bring this back to 0, 0. Order the parts, hopefully by the end of this video, and then depending on how much time we have, I might try and make these parts look a little bit more pretty, but I might also just leave them be for now, since they're probably not the final form, and I don't want to make them pretty because functional comes first, and then you add pretty on at the end, and if it doesn't function, then you have to undo the pretty and remake it pretty, and it's a whole lot of effort. So yeah, so let's add another stepper motor. Sorry, one moment. Cool, so let's start with our assembly. So to go over what we got here, we have these metal rods from McMaster Carr. Everything, whoops, that should be, everything that is blue, or everything that, let's make everything blue first and then jump back into this description. Cool. So now, everything that is blue is tentatively going to be 3D printed. These metal rods, still don't know where to get them from, but I believe this is a 1/4 inch diameter and this is an 1/8 of an inch diameter. Totally winging it with these diameters for now. Might have to adjust them depending on bending and things like that. But yeah, and then this motor, I just grabbed a model off of SparkFun as a placeholder for a larger model that we'll add in there, or that just might be the motor we get. We will see. I'll have to do some calculations of torque and things like that to see if this is the right motor. So, with that said, let's see, what do we want to do? So I realize there's an issue actually, which we might have to step back, is this motor attaches from the top with holes there, and I can't bring those screws up from the bottom, which I assumed I could, which means I might need to flip this motor over. Which means this design does not work at all. If I flip the motor over, I mean flip it, rotate it this way so that these holes are on the bottom, and then I can screw it in. And then maybe this cylinder here will run through the bottom, and I can run it along there. But then this cylinder interferes with this hole, so I think I need to modify this part first. Maybe extend it back a little bit further so that these holes and this hole don't interfere with that. All right, so let's see. Probably first want the diameter of this is 5 millimeters, and the height of it above this surface, 5 millimeters and 24. I'm going to jot these down in my notebook so I don't have to come back and reference them again. So 5 millimeter diameter at a height of 24.25. And then we have this other little lippy bit here, which sticks up 2 millimeters. It's got a diameter of, oh, what is that? Try that again. Diameter is 22 millimeters. Cool. So, okay. So probably want to move these holes back and then use them as a reference to do the final center hole. So I think in the I think this is going to be easier if we remove these first. So these holes, I believe, we're 31 millimeters square from each other. Yes, okay. Just jotting this down real quick. And they were 3M. Cool. So, if we come back here, we'll get rid of this. And we want to do just a sketch for reference. Actually, let's expand this extrusion out first. Cool. Okay, so okay, so we actually want to edit this sketch. And this hole should not be center. Oh. Cool. So add that line in that I accidentally deleted. This needs to be bigger. Let's bring it out a little bit for now. Move this rail a little bit. Ooh. towards the front. Cool. Okay, I know the assembly is going to fail. It's missing relations. Let's see. Yeah, 'cause these holes don't exist anymore. Cool. This part's going to be fun to build. Okay. Okay, so up top, hold on. Oh, I totally opened the wrong part. There we go. Okay. So we'll add, for reference, this will be the sketch that everything else is based off of for doing the. Oop, Jesus, sorry. Everything else will be based off this sketch for doing the stepper motor and attaching it. So we know that the distance between holes, the hole centers will go in these 4 points, and then the shaft that passes through the middle will go right through there. So center line through here, throw a little circle on it. Actually, leave out the circle for now. Cool. So everything here will be for construction. Which means now we should be able to use this sketch to do the hole wizard and do the center point. So we are using the M3 counter bore, and if we position them here, 1, 2, 3, 4. Cool. And then if we do another sketch here, do a circle based off. Actually, first, if we convert entities, we can use this for construction in this one. And the outer diameter of the sticky bit that I called out was 22 millimeters. So let's do this 24. And we'll make that an extruded cut through. Cool. So that now gives us, I believe, if I come back here, and now we can just drag this sketch around wherever we want. So we put it there and come back. Holes are over there now. Which will allow us to kind of play around with the positioning of this guy. And putting it there doesn't make any sense. So let's move it about. Bring it roughly back towards the center. And now we can kind of eyeball it. So I think that doesn't work because you can already see it intersects the rod that's going to go through there. So let's pull it back. Right there might be good. Let's see how that looks. Cool. All right, let's go see how it looks. All right, so this guy should not be mated with that surface anymore. We're going to try this again. Oop. This shaft should be concentric with this. I'm going to flip it around. Whoops, that's not what we want to do. Let's go the other way. Cool. And I think we should be able to get the last mate if we come up through the bottom. This is going to be a little weird. This one and that one. Perfect. Alright, this moment of truth. Does it stick out the bottom? It does a little bit. Interesting. So that's actually kind of cool. I do want to experiment with rotating this guy 45 degrees because I think that it'll actually fit a little bit nicer in here. And then we can move this motor back a little bit towards the center. So, wrong file. Alright. So, let's see. How do I want to think about this? Okay, this is actually not what I want to edit yet. Alright, so if we give an attempt to bring this a little offset from the center, maybe 10. Cool. And then, totally eyeballing this at this point, but we'll see how this goes. Ooh. Let's see if this can convert this into two selected face. Ah, how about this guy? Oh. Oh, can we do this? This would be cool. Awesome. This is me experimenting with things I've never tried before, but we'll see how this goes. Oh. It's not what I meant to select. All right, we select them both, make them for construction. Did I get them? For construction. Okay, cool. So this tells me exactly where this hole is, and I believe if I then edit this and change that value, the sketch should rebuild and move it down. So I know exactly where it is, and then I can position all these holes accordingly. So I guess the first thought is, can I get this rod to pass through this gap here, which I don't think so. But we now have a sketch we can play with. So we want this and that. We want an angle, 45 degrees. Nope, that didn't do what I thought it would. Because they've, okay, let's remove these. And instead make these parallel. And these parallel, which should now allow me to add in an angle here of 45. Nope, really doesn't like that. Why are you stuck like this? You're just parallel to each other, and there's no other relations. Oh, there we go. Cool. Okay, almost there. I think we should make sure that this is actually 90 degrees. Oh, it's like almost perfect. Use a smaller rod. No, that feels silly. Let's try this design out without it for now. So, let's bring these back. Oh, we'd have to extrude even more. That's a bit of a bummer. Maybe 45 degrees is not the play. Too bad. Okay, so I know we definitely want this. I think if I make this vertical, it should now be centered along this. Yeah, cool. Okay. How's that look? Doesn't need to be extruded as high, so can I get it down to 10? That might be too little. Oh. Whoops. Okay, so we need to deal with this and that and this. Let's see. Are you still there? You are still there. Cool. So a 2D plotter. I'm going to step to the chat real quick. Sorry, I'm very new to having people chatting. So the idea of a 3D plotter, 3D printer. Let's see. There's lots of different kinds of things I'm throwing around here. A printer like that you connect to your computer that prints out just like text that you open in like Microsoft Word and you hit print. That's 2D plotter. It's basically just you can move in two different directions, the X and Y direction, and then output ink onto paper. So let's see if I go back to Instagram. So I made this little guy, which is kind of the idea of a 2D plotter. It's basically just printing out the alphabet here, dragging a pen along one line at a time. And yeah, and then you can attach kind of whatever you want to this little bit here. And it's almost like a 3D printer because you still have to like lift the pen up and drop it down to like drag it along the surface. But yeah, that's generally what we're building towards here. Cool. All right. How do I want to deal with these holes? Man, I can see this part is a little annoying, and I suspect there's going to be an even more annoying part that I'm going to have to build. Can I lift these holes up and not have them? Let's start here. Okay. Oh, I've made a mess of things. Okay, so this doesn't make any sense anymore. This should be centered, I think, on this face vertically. I don't know if it makes any sense. Maybe it will. Maybe I'll come back and be like, why did I do that? Cool. Okay, so now those are centered vertically. I think for rigidity, center makes sense. Might be talking about my butt. It's been a while since I've done actual mechanical engineering. Cool. What do I want to do here? So there's supposed to be rods coming through here that go all the way back, and now they're currently intersecting this tube, which has another rod in it, and that shouldn't be happening. So I guess we'll just make the part bigger for now. This feels lazy. Don't want to do too much more. Cool. Ooh. All right, let's try and do some fixing here. So I think this line's not set yet, so let's make it just very close to the edge. Won't let me do that. Cool. Did I just... Oops. Okay, cool. Undo is your friend. No, you don't want to do that. Okay, so I can move you about, but I can't set your dimension. Yeah, I'm glad you feel inspired. I love building stuff. I tend to rewrite my portfolio all the time. I don't like to take forever on projects. I get really bored really easily, and a portfolio is a thing you can kind of quickly do. So, yeah, glad to have inspired. Cool. Thanks for joining. Take care. All right, why do you not want to fit? Ooh, that's not what I want. Oh, you've somehow attached yourself to the origin. Okay, let's get rid of you. Let's try this now. Nope. Still something here is conflicting. Oh my gosh. I just want you to go away. want this to yell at me. Yes, yell at me. It doesn't like parallel. That makes no sense. Whatever. Yes, go. What? There. That makes no sense. Oh my god. Okay, whatever. Cool. I swear I like understand CAD and then I never do. What did I even draw this line to? Just want you to be vertical. There we go. Okay, now fully defined. It means it should be where I want, which means now I can drag this closer to the edge. I think 3 should still leave it with 1.5 millimeters from the edge. No, a little too aggressive. Okay. Cool. Looks good. All right. Cool, cool, cool. So now I can drag this hole back. I just measure here and here. So that distance is 16.5 millimeters roughly, which means I can move the circle 16.5 that way. Okay. So 20 minus 16.5 millimeters. Cool. Okay. How does it look see-through? Are things conflicting? No. Okay, which means now, if we measure the distance between this surface and here, that distance is 18 millimeters, which means I can slide and make this part smaller by 18 millimeters. I think I did that right. Oh, the center moved over. No. That is, there we go, okay. I think it's not where I want that dimension from. I think the dimension from be from this back line. Cool. So if I collapse this by, let's go minus 17 millimeters. Okay, that should, cool. We could slide that circle back like another 1.5 millimeters. Go 42. Cool. That looks nicer. Sweet. So originally I had these kind of weirdly spaced out to avoid conflicting with these holes, but now that there's further back, I probably just slide these over a bit. Like 30 should be good. Cool. And then I can hopefully reduce this extrude and everything will just remain centered. Fingers. Oh my gosh. I've gotten better at designing over the years. I swear in the beginning I used to design things just terribly. But that actually kind of, that might be our part. Sweet. I'm going to do a little bit of OCD measuring. And this thickness is 111 millimeters. Just, you know. Cool. Did I do the math wrong? Oh, I did. Oops. How did I do that? 42. Okay, interesting. Okay. Now it fits flatly on there. Kind of sticks off the edge, but whatever. Okay. I think now these rods can be mated into here. Oh, what is that mated to still? Cool. Sorry, I should reply with text real quick. All right, and I'm back. So let's get these situated in here. Cool. And that's already fixed. Oh, that is sweet. All right, so it looks like I should be able to adapt. What are the chances I can find that model? This guy. Engine belts. Can I get it off GrabCAD? I can. Alright, so I feel like I don't actually know which one I need yet. But we're going to grab one of these for now. Alright, body 2. Just opening the zip off screen. Bottom base. Let's see what this guy is. Cool. This is totally not the right size at all, but we're going to use it for now. Just to give a ballpark. That sticks out nicely. So you can imagine this just spins here. Cool, cool, cool. All right. So then I think we want to modify this to be roughly, I mean, we need to match up the holes because they currently don't match up. But then also we can run this belt along the bottom of here and connect it somehow, and that would give us kind of our motion in this direction. And then if we add another one of these, I think I'm going to look at my 3D printer real quick. Okay, so it looks like we need some kind of we don't need teeth on the other side. We just need some kind of disc that this can adapt to on the other side. So, okay, getting a little bit ahead of myself. Let's edit this part first. So, the height of this is 12 millimeters. I'm going to jot this down in my notebook. And the hole distance is 30 millimeters. And it runs, I believe, so this value here should be 6. Cool. Okay, so we have our dimensions that we need. Cool. So that is not the, we actually want to edit the sketch for this. 30 millimeters. Oh, between holes, that's not what I want. Oh, I can't even, boo. And that distance is 42 millimeters. Ooh, okay. Okay, okay, perfect. 42, and it was a height of 12. And then the holes. We're not at the center. Let's make them horizontal. Up. Cool. Right? No. And then this needs to be 30. Cool. Does that really make sense? No. Until I measure the wrong dimension. Oh, give me the measure tool. Oh my gosh. All right, so that should be 42. What? It is 42. Did I do this wrong? Ah, it's the extrusion that decides that. So this is 42, which means this is now square. Cool. Perfect. Okay. So up next, sorry, just a moment. I've also got a 3D printer going behind me, so I'm just keeping an eye on my prints because it's making a little bit of noise. Hopefully you guys can't hear that. All right, so I think up next is we want to duplicate this part and modify it to underneath having a holder that can receive this guy over here. So let's see if I can do this correctly, because last time I hit the wrong button. Save this document with a new file name. No. Save as copy. Okay, so I believe this is what I want. What did I call the other part? I called it plotter. None of these names are correct. Terrible name. Wheel holder. Why not? Okay. So to check that I didn't totally bork this, I'm going to remove something, and if I did this correctly, it shouldn't yell because the hole should still exist. Cool. I can delete this, and hopefully I should be able to insert. No, that is not the. All right, man. You'd think I had a developer. I can't name anything. All right, so this is the part missing the hole that I want to work with, which will go on the end over here. Cool. All right, so we don't need this. We don't need this sketch. We don't need this sketch. So this is what we were working with. We need something. Let's visualize this. Cool. So this will have a belt wrapped around it, which will attach to this and then run down to this piece that'll be sitting down over here. It doesn't need to be this big. So that's one. We can chop off all this material back here. I think we can totally get away with running the belt right back here. Let's try that. And I think, don't actually know how I'm going to attach it. So This original idea, I think it was just a nail. Yeah, that's most definitely a nail. Or is that a nut? I don't even know what this is. This might require a little bit of work, but I don't necessarily need to design it now. All right. So we can just collapse all this down. This might want to be too thin. If you go 40, maybe 15? That feels good. And then maybe some kind of rod that sticks in right there. Sure, why not? I didn't even give that whole dimension. Looking at my calipers, how big do I think this needs to be? Maybe 2.5 millimeters would be sufficient. Cool. All right. So this rod is now way too long. Yeah, so you can measure. Let's try measuring. So that distance is 4 millimeters. So if we shorten the rod by 4 millimeters, it should fit pretty nicely in there. So we should see these collapse. Boop. Perfect. Wait, did the rod disappear? Oh. Totally didn't extrude that correctly. Cool. Whoops. Alright. No. So the rod goes in that far, and it's... what do we got? What do we got? Reduce it by 10. Okay. I think 419 was what it was originally. Alright, now it should collapse into the perfect spot. But that's not. Can this rod move? Oh, it can. Okay, interesting. Yeah, whoops. Okay. So let's mate. Double check everything. So that should now fit in there snugly. Fits in there snugly. Cool. All right, let's make a little pin that we press in there. I really don't know what part we need. A threaded rod or a screw? This feels like a tried and true thing. Like a bearing of sorts? Ooh, okay. Maybe a ball bearing is what we want. Ball bearing. I think a ball bearing is what I'm going to end up going with. Yeah, so ball bearing press fitted? Is that a thing people do? Heck if I know. Okay, so we had assumed a shaft of... I guess we don't really care about the shaft, we care more about the outer diameter. Because that hole size can be adjusted. So, if we assume that the belt will be roughly, say, 11 millimeters in diameter, because I'm thinking the belt's going to wrap around here and want something equally sized. So something with an outer diameter. Wait, is outer diameter not a thing? Okay. Hmm. Is 0.4 inch. Oh gosh. What is the closest fraction? It's 2/5. It's probably around 1332. That's such a number they don't have. 13/32 minus 3/8. Okay, 3/8 is probably close enough. $6.21 each. Oy. I don't know what part I need here. Oh, let's just wing it for now. Let's assume we have a pin. So this hole was what? 2.5 millimeters in diameter. Cool. I guess it doesn't need to go all the way through the hole, actually. You do it halfway. I think it's going to be upside down. Chances is upside down. It's totally upside down. All right. Let's offset. No, can't even do that. Blind. There, that's what. Oh, I'm editing the wrong part. Whoops. So we want you offset by 10 millimeters. The other direction, maybe not 10, maybe 5, 3. Make you 8 millimeters deep. No. Cool. All right, so if let's see, that means there's a 3 millimeter gap between the top surface. That should be enough. Cool. Let's edit that because that's not where we want our mate. Chances. Cool. Perfect. All right. How does that hike? Ooh, that's pretty good. Oh, did not mean to do that. Let's get normal to you. Cool. So we want to extrude you just a little bit more. 5 should be good. Cool. So I think lastly we want a disc. That is the height. 7 millimeter in height. Let me write this down. We want a disc that is 7 millimeter in height. We want its diameter, I think I said 11 millimeters. Yeah, we'll go a little greater than that. Maybe a little valley of sorts. Maybe those are the dimensions of the valley where the belt will sit. We want to keep the belt in place. So I envision for this kind of a little H shape. And I'm doing a revolved piece with this. Ooh, I'll fix that in a second. Okay, so this should be vertical. It should be equal. It should be equal. It should be equal. Cool. All right, perfect. Okay, so I said this guy is going to be 7 millimeters. The inner diameter is going to be 11, so that'll be divided by 2. We'll probably want a little height, be 2 millimeters on either side. So 2 plus 2 plus 7, 11. And then the distance to keep the belt in place. The belt is probably a millimeter thick. So if we make this 2, and then make these 2 collinear, that should be our part. Actually, that's not our part. Almost. We need to make space for our pin. And our pin was 2.5 millimeters in diameter, which means this line needs to be offset by half of that. Cool. And now we can do a revolved base. Sweet. No, that's still not correct. We need an origin line to make that work, I think. Let's see how this goes. Yeah, there we go. Hey. Perfect. So now, we insert our disk. Ooh, where'd it go? Let's try that again. Okay, there we go. Perfect. I have no idea how this disc is attached at this point, but we'll say that's more or less where we want it to be. Cool. So I've never really modeled belts in CAD before, but I think the belt would run from here to there. We're going to leave it out for the scope of this. Or just to simplify things, I should say. This color is going to be a 3D printed part until it's not a 3D printed part, so we'll make it blue. Cool. Cool, 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 cool. Alright, so I think the last part to get this guy working is to give something that the belt can attach to. So I think really just... Oh, I've had the worst idea just now. I was thinking, so the belt is going to run along here, and it's going to cross over here. And so if I just extruded more plastic out and then use basic binder clips, I could attach the belt to this. But that feels wrong. Cool. Sorry, I'm just going to close my window real quick. It's getting a little noisy outside. All right. Okay, I have an idea that... Okay, I think I'm actually going to leave that be for now. Cool. I think whatever mechanism we get going here, we're also going to use to move it in this direction. How are we looking with that to do? Add another stepper motor. Didn't do any of these things, but we're getting close. We're making progress. So I think, so a random experience that I had before is, this is from the previous 2D platter that I built. So I'm trying to figure out where I want to place the additional belt that moves this guy up and down. And if you place the motor on this side, so you can imagine the motor's grabbing on here, the belt's attaching somehow, and it's moving this whole thing. So it has to move this whole thing and all of this. And I'm going to jump back to my days of mechanical engineering grad. The amount of effort that is required if the motor's on this side is that it's both the distance from here to here and then from here all the way over to here. So it has to carry all this weight, which is kind of a lot of weight. I mean, relatively speaking, if we're saying this piece is light, it weighs almost nothing. This piece is maybe, if we're going by volume, 1/3 heavier, and then this motor, that's a bit to move. And so, if instead we put the motor on this side, move it up over and down over here, maybe put it right here, it only has to move this motor from here to there instead of having to account for this whole distance across. So I noticed this in this previous design that kind of as I move this side would lag along, be a little bit sluggish. So if I put the motor on this side, there's less effort on the motor's part. And I noticed that you get jerky kind of motion, or you can avoid the jerky motion if you do it on this side instead. So I kind of want to put it on this side because then like another belt getting in the way of this guy kind of just feels bad. But it'll move easier, I believe. I believe it'll be worth it if I can design it correctly. So how am I going to design it? Let's just throw motor out into space. I think roughly about where I want to put this motor. Cool. This is roughly where I think the motor's going to live. I still have to design some part here. But so similarly as what I'm thinking here is that how I talked about this distance from here to here and here to here is kind of being too taxing. You have a third dimension of taxingness, I guess you could say. So if it's here, it's almost in line with this motor. Whereas if I move it way down, we're going to have to go up and then over, which is also added strain on the motor, which we don't want. Okay, I've had a completely different idea, which I'm kind of hyped about. Okay, so if I take a threaded rod, so I've seen in other designs where you can, so see this rod right here, you can attach that to a motor, and then if we made this the thread, oh god, let's not do that. If we made this a threaded rod and we attached these little holes to this guy, we could just slide him back and forth and thread this shaft, which would be rather nice looking. I kind of want to do that. Let's do that. Oh, this is gonna be cool. Cool. All right, so we need a threaded rod. What even does this offer? I've never purchased a threaded rod before. So what do we got? We have a few different designs. This looks maybe cheapest. Internal ball bearings provide smooth, low friction travel. That sounds like kind of what I'm building. This is probably stupid expensive. Ooh. No, we're not doing that. Precision Acme nut screws. That sounds good. Fast travel, precision. I'm going to guess that this is probably still more expensive. Okay, we're getting into reasonable prices now. What are we dealing with? We are dealing with... We need something that is about 400 millimeters in distance. The length, of course, is in inches. So 15 inches. inches. That is okay. This $18. Quarter inch. Let's see what we can get for that distance. 18 inches in length gets you down to a quarter inch at $9. That sounds reasonable. What did I click on? Fast travel. I kind of want fast travel. I suspect these are probably both. Let's see how these are priced. More expensive. 18 inches, yeah, it's twice as expensive. Be more expensive. All right, so we'll go with this. Let's go with this. Let's go 18 inches. Let's get this CAD model. It's just the threads or just give everything? Let's find out. Just the rod. Interesting. How about the piece that sits on top of it? Where's that piece? Multiple threads. What is this piece called? Heck. Just gonna look for nuts. I don't see it here. Component, this is the lead screw. What am I missing? Why does it not give me the other part? Alright, I will be right back. I have a quick phone call to take care of. Alright, sorry about that. Alright, so Acme nuts. Sweet, I think. Do none of these have holes? Wait, what? Precision. Okay, please tell me if. Okay, perfect. Here we go. Ooh, that's pricey. It's not even what I want. I want just. Okay, here we go. Threaded onto externally threaded Acme nuts to create a custom flange nut. Cool. Alright. So I believe if I grab that part that I downloaded, throw it in there, and then I download. Okay, so I downloaded quarter 12 thread size. Wait, what? That was. The thread size is quarter 12. Can I get a quarter 12 in here? There we go. All right. Ho-ho! Jeez. So this part that where this or one is $9. The only quarter 12. How? Are they all this expensive? They are all this expensive. Okay. Is there some other way I can attach it? So flange is not good. Ultra precision. These are probably stupid expensive. Yep. Wow. I didn't think. Wow. I did not think these would be so expensive. Holy moly. Is anything cheap here? That's a bummer. Peeking at my 3D printer for inspiration. So maybe we don't want. I don't know what we want. What does Acme turn up? Pretty sure this is just where I was. Could just get a nut of that size. This might actually work too. Oh, that's also stupid expensive. Holy moly. Are any of these cheap? Doesn't even list the thread size that I'm working on. No, that's. Doesn't even have a quarter 12. Okay. This is a pain in the butt. Okay, so let's let's assume price is no barrier right now, and let's roll forward with this stupid expensive solution that I've come up with. Nope, this doesn't even have the quarter 20 I want. Quarter 12. Which one of you has quarter 12? At this point, it actually doesn't even really matter because I'm not going to order that part. Quarter 12. Let's say I went with this. $37. That's rough. I feel like I could print something cheaper. But anyway. This is threaded rod. That is not even the. Oh. This is rough. Okay. This might require some additional research outside of chat because I don't want to bore y'all to death with finding the proper threaded rod that runs along here. All right, so chances we get an STL for this. Not what I want. Here we go. Cool. Okay. That might have been the wrong choice. Oh, gosh. Oh, this feels. Ah, whoops. I think I've saved her. Oh, let's just get out. That was a mistake. Yep, got it. Don't do that. Alright, let's grab just a threaded rod that's actually kind of long. The length, we need it to be 40 millimeters. 40 centimeters. If I can spell inch correctly, 15, 16 in length. Let's go 18. Cool. Let's grab this cat metal. Just drag that in. Alright, how much did we lose? Hopefully it's all still there. Looking good. Oh, we lost our additional stepper. Cool. Didn't need it anyway. So let's bring in our super long threaded rod. That is not the rod we want. Which one did you try again? 98957A. This. That's a lie. Is that really the part I just downloaded? 98957A112. Did it not say its length is a foot and a half? The length is a foot and a half. That's a lie. What is happening? Yeah, 1.5 feet, right? At a quarter 20. Am I reading this correctly? Threaded rod, quarter 20, at 1.5 feet long. What if we get the larger one? Is this correctly sized? This also says 1.5 feet. What is happening? This is not the part I'm looking at. Alright, are you going to be properly? Let's find out what you look like. That does not, it's not 1.5 feet. Okay. Let's assume this is the threaded rod because this appears to be wanting to fight me. We're going to want to make a copy of this part, keep the whole pattern, and figure out how to attach it to this. Right? I think it's just a screw through the top. Yeah. Cool. So we want to merge this part and this part and make a new part. Cool. All right. So we don't need these holes, or this sketch doesn't need to sit. This hole's unneeded. That distance is unneeded. Cool. Whoops. What'd I do? Referencing holes that don't exist anymore. That's fine. Cool. That's all we need, at least to begin with, to start to grok this part. Cool. So we insert. Stepper holder should go over here. So if this stepper has the same base as this, I think it's what, 25 millimeters? Yeah. This could adapt to this. This is gonna be gross, but we're doing it. Alright, so if we sketch on this surface, come in normal. No idea why I'm, well, shameful that that's not the center of this component. So now I have to draw new center lines. And another center line. Where is there? There's a cool. You vertical, make you horizontal, make you 2 coincident. That is now center. Dimension you out at 25. Go this way at 25. This model feels bad, but I feel like I'm going to throw it away. So, see what happens. Alright. So now, if we strew this up 25, go into our model. That is the thing. Come back here. Ah, bummer. This is totally not going to be, this hole is going to be an issue into this model. So if we slide this back, let's do that. So I never know which coincident. Oh, I got that right. Cool. I think. Yes. Okay. So we want this to actually be collinear with this, and then this line to extend up here. It's not actually where I wanted to bring this down to the center. Make these coincident. Just make it fully defined. Cool. Haha, that's awesome. This is what I want. I want to raise this up a little bit. Just give a little bit more space there. Cool. That looks good. All right. So now this is starting to look like that. This whole diameter is 12.6. Okay. Oh, is it a whole wizard? I think this is whole wizard. That is flat machine head screw, M6 flat machine head screw. Cool. Okay. I need to think this through. Also, the square's on the wrong side. Okay, so let's move this real quick, and I will show y'all what I'm envisioning. These lines should not be collinear. These lines should. Because I want to offset this. Okay, this is hard to explain, so y'all just need to hold with me for 1 second. So now, through this surface, if I drop, don't actually want to do that, whole wizard, through this surface, I want, what did I say, an M6 flat machine head screw. I think it's this guy. Flathead screw M6. Cool. Position that on this surface. Cool. Do you want to give me the holes? Wait. Oh gosh. Where'd my sketch go? Oh well. Cool. Okay, that's almost. Probably want the screw a little bit further down. What was that setting? Offset, offset, offset. Head clearance, far side. No? Is this one? Yes. Get it just a little, a little bit further down in there. Cool. That looks good. All right. This is almost where I want it. Actually, just delete this now. So this center goes here. That didn't get it right at all. Let's flip that around the other way. Cool. Get out of this weird ass view. Awesome. Perfect. Okay. So this goes this way. Cool. And then last. Perfect. And now, nope. Nah. You're going to be concentric with this. Facing the other way. Perfect. Oh, whoa. What is happening? Back it up. There we go. So now, this is like so close, but so far. This rod needs to be here. Oh gosh, what god awful thing did I just do? Does that work? Interesting. Okay. This is weirdly acceptable and unacceptable because we're at a weird slant. Uh, so there's like a few different things I can do here. I can, if I wanted to have 4 parts be exactly the same, so 1, 2, 3, and 4, I need to modify this printed part. Or I could just lower this all the way down. I feel like I want to make a copy of this, extrude it less, and just leave it there. At least as a first iteration. Because nothing really is coming to mind. Oh, let's do that. Okay, so I thought this was a SolidWorks part. I think it is. Yes. No. Yes. Awesome. Okay. So we will say this. All right. I wouldn't just bork everything. What is this part? Okay, so this part. Oh. Okay. Cool. Oh, this is fun. All right. So let's see if I made this. This should hopefully give us the height of what this beam needs to be. If I made these and make these parallel, make these surfaces parallel. Did it assume it's parallel? Cool. Okay. And now if we measure, that distance is 19.5. I feel like this part needs to be edited. It should not be that. Because I think these holes do not overlap, and this can actually be made smaller. I think it's the sketch we need to edit. Can I get away with making it? Okay. Yes, we can do this. So this, where's this extrusion? This extrusion does not need to be this high. 15? Which means I can continue to shrink this. Okay. Just can't interfere with the rod, but this is like for the most part fine. I mean, this might actually be fine. Sure. Oh gosh. Went too deep with this needs to be edited. So I think this should be at this point. It could just be 0. Oh, no, no, no. I don't know what I just did. Try that again. Make this 0. 0. Hit 9. Let's try it again. Could we go lower? I don't know if that'll be rigid enough. Or if I can even assemble this properly. So it's like, oh man, I'm totally gonna have issues when I try to assemble this. So how do I need to figure out how to get this screw on. So this shaft in, and then this screw here tightened. Let's worry about that later. Let's make this look like I planned this. Make these two to be concentric. Are they? They are. Alright, let's measure now. So new extrusion height, 44.5. Perfect. No, let's insert, not what I meant to click. Insert component. Cool. Oh. Sometimes aggressively hitting the escape key doesn't quite work. All right. Cool. Oh wow, that actually looks legit. I really like that. I wonder how rigid this connection is. I feel like I'm going to 3D print this part again, where I'm going to have like some support that it's like right in here, like a triangle. Maybe have to expand this out. Oop. This surface to the edge of this surface, and then go deep with the screws. But that looks good. I don't know what the opposite end of a threaded rod looks like, so I don't know what this side's going to look like yet. I feel like that's also going to require some additional research offline. This might actually be our stopping point. Because I still don't know how I'm going to transmit this rotational, this rotating to this moving this way. Which I need to figure out. There's a few things I'm going to need to do some research on. Did we hit anything in here? No. Find how to attach belts to stepper motors. Let me say that's done. How to hold the pen in place. Not done. Figure out how to lift and drop. Nope. Add another stepper. Did that. Cool. So we can say move these down. So we don't need the X then. Cool. I think at this point I need to do some research, and I will circle back around in the future. Perhaps next time, for the next stream. Cool. So on that note, thank you everyone for joining me tonight. I'll probably be back again tomorrow, Tuesday night, with a new stream after I do some research. Hopefully I'll be able to summarize the research with you. And yeah, thanks for joining.